This is WAEC June 2022 General Mathematics Paper 2, and we are answering question number 6. And the question says that the graph shows the relationship of the form y equals to mx squared plus rx plus r, where m, n, and r are constant numbers. This is the graph displayed here. So the questions that we answer from this very graph are A, state the scale of both axes. So you have to now mention the scale used in this drawing of this very graph. Question number B, you ask to find the values of m, n, and r, these constant numbers. So question number C, you ask to find the gradient of the line through P and Q. There is a straight line which passes through point Q and it passes through this point P. You have to determine the gradient of this very line. And question number D, you are asked to state the range of values of x for which this very curve, that is y, is greater than 0. So let's attempt to answer this very question together. So starting with the very first question number A, that you asked to write the scale on both axes. That is the scale used in this very drawing. So if you look at your x-axis, from this 0 to this positive 2, you can see it is 10 small divisions here, because between each two thick lines it is 5 small divisions, and each of those 5 small divisions represent 1 centimeter. So from this to this is now the 2 centimeter. So which means from 0 to 2 is 2 centimeter, 2 to 4 is another 2 centimeter, 4 to 6 is another 2 centimeter. Is the same applicable in the left part of the x-axis. That is 0 to minus 2 is another 2 centimeter. Minus 2 to minus 4 is another 2 centimeter, which means the scale here on the x-axis is the 2 centimeter, representing 2 units. So now write 2 centimeter represent 2 units on x-axis. You can equally write 1 centimeter to 1 unit because you can divide it through by 2. So this is the scale used on the x-axis. So you now move to the y-axis. From 0 to this to 10 is 2 centimeters. 0 to minus 10 is another 2 centimeters. Also minus 10 to minus 20 is another 2 centimeters, which means on the vertical axis, that is y-axis, is now 2 centimeters to represent 10 units. This also you can now divide through by 2 to get 1 centimeter to represent 5 units. If you write that, you are still okay. So question number E has been answered. We move to question number B, that you asked to determine the values of m, n, and r, that is these constant numbers in this very function. So to do that, you now build this very quadratic equation that is represented by this very curve. To build that quadratic equation, you need to determine the roots of the quadratic equation where the curve crosses the x-axis, like this minus 2 and this 4. These are the roots. So you now use these roots to build the quadratic equation. When you now build the quadratic equation, you can now compare it with what is given, y equals to mx squared plus rx plus r. That will enable you to find what will be m, what will be n, and what will now be r. So the roots of that very curve, this very quadratic equation that we have, it is graph, are minus 2 and 4. If you take minus 2 to the left in this very simple equation, you now have x plus 2 equals to 0. Similarly, if you take this positive 4 to the left, so you now have x minus 4 equals to 0. So multiplying the two zeros, that is x plus 2 and x minus 4, the result will still give you 0. So expanding this correctly and collecting like terms, you now have x squared minus 2x minus 8 equals to 0. But looking at our graph again, that is this very curve that is drawn. This curve that is drawn is a curve that has maximum value. Having maximum value means the curve started from the bottom, move up, and move down again at the turning point. This is the turning point. So it is at this turning point that the curve is maximum. If the curve started from up, down, and move up again, then it will now have a minimum value. So curves that have maximum value, the coefficient of the square term is usually negative, And in this very quadratic that I have just obtained, x squared minus 2x minus 8 equals to 0. The coefficient of the square term is positive 1. So we have to make this negative. So we now multiply through each and every term here by minus 1. That will now make this x squared to have a negative coefficient. So there I'm going to have minus x squared plus 2x plus 8 equals to 0. It is all through multiplied by minus 1. That makes minus 2 to become positive 2 and makes minus 8 to become positive 8. 0 times minus 1 is still 0. So this will now be the quadratic equation exactly that if you are to draw it, it will give you this very curve. You can now take this and compare it with what is given y equals to mx squared plus nx plus r. That will enable you to know what will now be m, the coefficient of the x squared, what is n, the coefficient of x, and what is r, the constant number. So if you now compare this and this, you now discover that the value of m will now be minus 1, because it is minus 1 here, the coefficient of the square term. The value of n is now 2, because the coefficient of x, which is here, n is 2 in this case, so n is equals to 2. And the constant number r in this very equation is now positive 8, so you have r equals to 8. So that answered question number B. So move to question number C. Question number C, we asked to determine the gradient of the line that passes through this P and this very Q. So to do that, we'll now find the coordinate of these 2 points P and the coordinate of this very point Q, or any other coordinates on the line. So the value of P here, if you move to the horizontal axis, it will give you minus 5 here. If you move here also to the vertical axis, it will give you minus 27. So let me just write it. You now have minus 5 as the coordinate of this very point P. The x coordinate is minus 5 and minus 27 is the y coordinate of this very point P. Similarly, at the point Q, moving to the horizontal axis, you have 3 here, and moving to the vertical axis, you have 5 here. So the coordinate of this very point Q is 3, 5. It is this coordinate that you are going to now use to find the gradient. Remember, gradient says a change in y divided by the change in x. So if you now substitute, you now have 5 this y value minus 27 this y value divided by 3 the x value minus 5 the x value in this very point. So you now have 5 minus 27 divided by 3 minus 5. Expanding this very bracket, minus change it to plus, so you have 5 plus 27, while minus change it to plus, you have 3 plus 5, and this gives you 32 divided by 8, and when you divide 32 by 8, you now have 4. So the gradient of this line that passes through P and Q is now equals to 4. That answered question number C. So move to question number D. Question number D asks to find the range of values of x for which this very curve has a value greater than 0. So the value greater than 0, you can see all here is the negative part of the y-axis. So on this very curve, after this very point, the y value is less than 0. Similarly, from this 4 down here, the value of y there will also be less than 0. It is only between this minus 2 and this very 4 that the y value here is positive, because it is in the positive y-axis. So which means the x value that happens y to be greater than 0 will now start from this minus 2 and end at this very 4. That will give us the range of values of x that makes this y to be something greater than 0. So now write the range to be equals to from minus 2 up to this 4, but excluded minus 2 and excluded 4, because at x equals to minus 2, y is exactly 0. Similarly, at x equals to 4, y is exactly 0. We are interested in y greater than 0. And this answered all the 4 questions. So let me just share with you the mark distribution of this very question as it is contained in the official WAEC marking scheme. So the very first mark is bonus 1 mark, and this bonus 1 mark, you have it when you now write the scale on the x-axis exactly 2 centimeter to represent 2 units, or like I have said, 1 centimeter to represent you 1 unit. Whichever one you now write, you have this bonus 1 mark. Next mark is another bonus 1 mark when you now write the scale on the y-axis as 2 centimeter to represent 10 units, or rather 1 centimeter to represent 5 units. You have this bonus 1 mark. Next mark is method mark when you now determine the roots of that very equation. In attempt to build the quadratic equation, you have this method 1 mark. And when you now have the quadratic equation exactly as y equals to minus x squared plus 2x plus 8 equals to 0, you now have this accuracy 1 mark. And when you now compare this quadratic with the one given and determine the value of m as minus 1, it gives you this accuracy 1 mark. N as to 2, you have this accuracy 1 mark, and r equals to 8, you have this accuracy 1 mark. So for each value correctly, you have 1 mark each. If I move, question number C. Determine the coordinates of P and Q from this very graph. That is the coordinate of Q as 3, 5 and the coordinate of P as minus 5, minus 27. For each of that one, you have a bonus 1 mark. And when you now substitute the coordinates in the formula for finding the gradient, you have this method 1 mark. When you now have the gradient exactly equals to 4, you have this accuracy 1 mark. And finally, for the range of values for x for which y is greater than 0, when you now have minus 2 less than x and x less than 4, you have this bonus 1 mark. So in total, this question number 6 has 12 good marks if everything is correct.